This lesson is going to focus on adding, subtracting, multiplying, and dividing rational expressions and how they might appear on the SAT. So one thing to remember when you're adding, first of all, rational expressions are just expressions where you have polynomials, or not even, it doesn't have to be a polynomial, it could just be a number, but they're dividing by each other, right? They're in a fraction format, right? So 7 over x or 2 over x plus 8, these are both rational expressions, right? And when we're subtracting these or performing any operation on them, it's going to be very similar to when you're dealing with regular fractions. So just like when you're subtracting fractions and adding fractions, you need to have a common denominator. You also need a common denominator for adding and subtracting rational expressions. So let's start with this first problem, right? Notice how there's no obvious common multiple for x and x plus 8, right? We need these to have a common denominator, but we don't know what an obvious common multiple is, right? So if there's no easy common multiple between x and x plus 8, what we're going to do is we're just going to use x times x plus 8 as our common multiple. So that's the easiest thing that we can use right now, because both x and x plus 8 can multiply into this. So now what we need to do is convert both fractions to have that common denominator, right? So let's start with 7 over x. If we want this to have a denominator of x times x plus 8, notice how we need to multiply the denominator by x plus 8, right? So then we also must multiply the numerator by x plus 8, and then we're left with 7 times x plus 8 over x times x plus 8. And now we've converted 7 over x to have the denominator that we want, right? Now we're going to do the same thing with 2 over x plus 8. So what we're going to do is we're going to multiply both the numerator and denominator by x. In this way, notice how the denominator becomes x times x plus 8, right? And again, when you multiply both the numerator and denominator by the same number, the value of the fraction doesn't change. Whether that number includes variables or whether it's just any constant number, we're allowed to do this as long as we multiply both the numerator and denominator by the same number. So now what we can do is rewrite our expression. We have 7 times x plus 8 over x times x plus 8 minus 2x over x times x plus 8. And now they have a common denominator, so we can easily subtract these. This becomes 7 times x plus 8 minus 2x over x times x plus 8. If we wanted to, we could, distribute the 7 and simplify it. I'm going to leave it like this for now. This is how we can subtract two rational functions, or two rational expressions. Let's take a look at this one now, right? Number 2, we have a similar situation, except now we're adding. So notice how, again, there's no obvious common denominator, so I'm going to do the same thing. For my denominator, I'm going to use x minus 3 times x plus 1. So again, to achieve that, for this first one, 2 over x minus 3, I'm going to multiply both the numerator and denominator by x plus 1. And then same thing for 5 over x plus 1. I'm going to need to multiply we already have an x plus 1 here, right? So I'm going to need to multiply the numerator and denominator by x minus 3. So notice how I'm sort of multiplying each fraction by the denominator of the other one. So for 2 over x minus 3, I'm multiplying it on numerator and denominator by x plus 1. And then for 5 over x plus 1, I'm multiplying both the numerator and denominator by x minus 3, right? And this way, 2 over x minus 3 becomes 2 times x plus 1 over x minus 3 times x plus 1. And then 5 over x plus 1 becomes 5 times x minus 3 over x minus 3 times x plus 1. And now, again, we can easily add them. So we have 2 over x plus 1 times x minus 3, 2 over x plus 1, 2 times x plus 1 over x minus 3 times x plus 1, plus 5 times x minus 3 over x minus 3 times x plus 1. And the added form is just 2 times x plus 1 plus 5 times x minus 3 all over x plus 1 times x minus 3. And again, I'm going to skip multiplying out the numerator for now, just to save some time. But yeah, the main concept is that if you don't have an obvious common multiple between the numerator and denominator, you can multiply them together to get your common denominator, right? And we're going to do the exact same thing here. Again, there's no obvious common multiple between x minus 1 and x minus 7, so I'm going to use as my common denominator x minus 1 times x minus 7, because that is a common multiple of both x minus 7 and x minus 1, right? Both of these can be multiplied by another number to achieve this, right? So that's why we're using it. So again, to convert 4 over x minus 1 to have a denominator of this, I'm going to multiply both of them by x minus 7, right? Because notice how 4 over x minus 1, we already have the x minus 1 part, right? We already have this part. We're missing x minus 7. So that's what I need to multiply by. So I'm going to multiply both the numerator and denominator by x minus 7. And then for this one, I'm going to multiply both the numerator and denominator by x minus 1, right? Because for 9 over x minus 7, I already have the x minus 7 part, but I still need x minus 1, right? So that's what I need to multiply both the numerator and denominator by. So for 9 over x minus 7, I'm going to multiply the numerator and denominator by x minus 1. And now the resulting expression is going to be 4 times x minus 7 over x minus 1 times x minus 7, and then minus 9 times x minus 1 over x minus 1 times x minus 7. And now we can subtract them since they have this common denominator. So I'm going to be left with 4 times x minus 7 minus 9 times x minus 1 over x minus 7 times x minus 1. Or x minus 1 times x minus 7. Okay. Let's look at this one now. This one is a little more interesting. Notice how we have, a little bit more of a complicated polynomial here. So what we're going to do here is we're actually first going to factor both of these polynomials, right? So for this first one, 2x squared plus 18x, I'm going to factor out a 2x from both of these terms, right? And I'm going to be left with 2x times x plus 9. And then for this one, for the second polynomial, it's a little longer. So I'm going to find two numbers that add up to 17 and multiply to 72. That's going to be, let's see, 8 and 9. So this is going to factor into x plus 8 times x plus 9. So now notice how my denominators are a little bit easier to read. And if we think about what is a common multiple between 2x times x plus 9 and x plus 8 times x plus 9, what we're going to do is we're going to use this 2x times x plus 9 times x plus 8. Now the reason why we didn't multiply both of the denominators together to get to a common multiple in this case was because both of these already have an x plus 9 term, right? So there's no need to multiply them together. They already share one common factor, right? But we still need to get 2x and x plus 8, right? So now this way, using this denominator, all we need to, this 2x times x plus 9 can multiply into this, right? If you multiply this by x plus 8, then it turns into this. And same thing with this, x plus 8 times x plus 9. If you multiply this by 2x, then it'll turn into this, right? So that's what we're going to do. So for my first fraction, let me rewrite our common denominator. This is the denominator that we want. So for my first fraction, notice how I already have 2x and I already have x plus 9. What I'm missing is this x plus 8. So that's what I need to multiply both my numerator and denominator by. So then this becomes 7 times x plus 8 over 2x times x plus 9 times x plus 8. So I just multiplied both my numerator and denominator by x plus 8. Now, for this second fraction, notice how I already have x plus 8 and I already have x plus 9, but I'm missing this 2x. So I need to multiply both the numerator and denominator by 2x. And then this becomes 5x times 2x over 2x times x plus 8 times x plus 9. Okay, and now they both have a common denominator. So I can easily subtract these. This becomes 7 times x plus 8 minus 10x squared. 5x times 2x is 10x squared. And then that's divided by 2x times x plus 8 times x plus 9. So to recap, the way that we found this common denominator was first we multiplied first we factored both of our denominators, right? And then we saw that they both share this common factor of x plus 9, right? So we're sort of like combining both of the denominators from these two fractions, right? So we took 2x and x plus 9, and then we also took x plus 8, and we didn't need to add another x plus 9 because we already have that, right? So then this becomes our common denominator. So just remember that your common denominator should be a number or an expression that both of our separate denominators can multiply into. Let's take a look at some more examples. So for this one, again, we're going to start off by factoring each denominator. So this one, if I find two numbers that add up to -8 and multiply to -9, that's going to be x minus 9 times x plus 1. And then for this one, if you factor x squared minus 81 using difference of squares, that's x plus 9 times x minus 9. And now to find my common denominator, notice how both of these already have an x plus 9. So I'm going to move that here. That's going to be in my common denominator. I also need an x plus 1. And I also need an x plus 9. So now I've sort of used all of the components in these fractions to create the common denominator, right? So this is going to be the common denominator that I use, x minus 9 times x plus 1 times x plus 9. So notice how this one already has x minus 9 and x plus 1, right? So it's missing x plus 9. So that's what I need to multiply the numerator and denominator by. So then this one is going to become, well, I'm going to multiply the numerator denominator by x plus 9, right? So this is going to become 9 times x plus 9 over x plus 9 times x minus 1 times x, this should be x minus 9 times x plus 1. And then for this one, the second fraction, notice how I already have x plus 9 and x minus 9, right? So what I'm missing here is this x plus 1. So I'm going to multiply both the numerator and denominator by x plus 1. So then this is going to become 2 times x plus 1 over x plus 9 times x minus 9 times x plus 1. And now they have a common denominator, right? So I can easily subtract these. This becomes 9 times x plus 9 minus 2 times x plus 1 all over x plus 9 times x minus 9 times x plus 1. Notice how once I have a common denominator between both of the fractions, all I need to do is subtract their numerators and I keep the denominator the same, just like regular fraction addition and subtraction. Okay, let's look at a couple more. So for this one, again, we need to factor both of these expressions first. So I'm going to have 1 over 7x times x minus 1 if I factor out 7x from both of these terms, right? And then for this one, I'm going to have 6 over, and I'm going to factor out again 7x from both of these terms, and I'm going to be left with x plus 2. So notice how I have 7x in both of these terms, right? So that's going to be part of my common denominator, 7x. I'm also going to have an x minus 1. And I've already counted 7x, so there's no need to add it again. But I'm also going to have an x plus 2 in my denominator. So now I have a common denominator that both of these separate denominators should be able to multiply into. So again, same process. For this first denominator, 7x times x minus 1, I already have 7x, I already have x minus 1. I still need an x plus 2, so I'm going to multiply the numerator and denominator by x plus 2. So then first fraction becomes 1 times x plus 2 is just x plus 2. Then over 7x times x plus 2 times x minus 1. And then for this second fraction, I already have 7x and x plus 2. So I'm missing x minus 1. So that's what I'm going to multiply my numerator and denominator by. So I'm going to multiply both the numerator and denominator by x minus 1. And I'm going to be left with 6 times x minus 1 over 7x times x plus 2 times x minus 1. And then again, I can just add these. I just add the numerators. So x plus 2 plus 6 times x minus 1 all over my denominator, which is 7x times x plus 2 times x minus 1. Okay, so that's it for adding and subtracting rational expressions. Now we're going to take a look at multiplying and dividing. So again, when you're multiplying and dividing rational expressions, a lot of the rules are the same, but there's a couple things that we need to add. All right, so firstly, let's take a look at this problem. So I think our first step is going to be that we're going to factor everything that we can, right? So notice how x squared plus 10x plus 25, we can factor that into x plus 5 times x plus 5. So two numbers that add up to 10 and multiply to 25. And then that's all over x minus 5. And then this is divided by x squared minus 25. If you factor this using difference of squares, you get x plus 5 times x minus 5. And then that's divided by 5x plus 10. If you factor out the 5 from both of these terms, then it becomes 5 times x plus 2. Okay. So one thing that you need to be careful of when you multiply or divide fractions is that a fraction can't have a denominator of 0. Otherwise, it's undefined, right? So this can't have a denominator of 0. So then that means that x minus 5 can't be 0. So we need to write down that x can't be equal to 5, right? Because if x was equal to 5, then x minus 5 would equal 0. Also, 5x plus 10 can't be equal to 0, right? So then x can't be equal to negative 2, right? Because if x equals negative 2, then 5x plus 10 equals 0. So now we're ready to start dividing these fractions, and we're actually going to use the same rule as you do with regular fractions, right? So if you remember that when you're dividing regular fractions, you use keep, change, flip. So we're going to keep the first term the same. We're going to change this division into multiplication, and we're going to flip this second fraction. So then this becomes 5 times x plus 2 over x plus 5 times x minus 5. And now one interesting thing happens. Notice how this fraction is now flipped. So now we have a new denominator, right? And this denominator is not allowed to equal 0 either, right? Because if any denominator equals 0 at any point, then the fraction is undefined, right? So that means that we need to add some more restrictions. X plus 5 can't be equal to 0, which means that x can't equal negative 5. And x minus 5 can't equal 0 either. So x can't equal 5. So we already have x can't equal 5, so we're going to add x can't equal negative 5 either. Okay, now all we need to do is multiply these fractions. And one thing to note is that it doesn't matter if your numerator is equal to 0. The numerator of a fraction is allowed to equal 0. It's just that you have to be careful that the denominator doesn't equal 0. But now we can multiply these fractions. So if you look at and again, when you're multiplying fractions, you're just going to multiply across, right? So numerator times numerator, denominator times denominator. So on the numerator, we're going to have x plus 5 times x plus 5 times 5 times x plus 2. So we can write it like this: 5 times x plus 2 times x plus 5 times x plus 5. And then on the denominator, we're going to have x minus 5 times x plus 5 times x minus 5. So I'll write it like this: x plus 5, and then we have x minus 5 and x minus 5 again. So what we can do now is simplify this result, right? So notice how we have an x plus 5 on the numerator and denominator. So I'm going to cancel out one x plus 5 from the numerator and denominator. I can't cancel out this other x plus 5 on the numerator because there's no other x plus 5 that I can cancel out on the denominator. So I can only cancel out one in this case. So then this becomes 5 times x plus 2 times x plus 5 on the numerator. And on the denominator, just x minus 5 times x minus 5, which is x minus 5 squared. And we need to add in our restrictions from before, that x can equal 5, negative 2, or negative 5. Even though this is a different fraction, since this fraction originated from these two, it's not allowed to equal those specific x values. Let's take a look at another problem. So for this one, we're multiplying the fractions. This will be a little bit more straightforward. Let's start off by factoring everything that we can. So we can factor this numerator, right? We can factor out a negative 3 from both of these terms. And that becomes negative 3 times x minus 7. And then on the denominator, I'm going to factor out a negative 2 from both of those terms. So negative 2 times x plus 2. And then over here, I can factor x squared minus 16 using difference of squares. So then that becomes x plus 4 times x minus 4. And then the denominator, it can stay the same. Okay. So now what I'm going to do is add some restrictions. So notice how I can't have this denominator or this denominator equals 0. So I'm going to add in that x plus 2 can equal 0, which means that x can equal negative 2. And x minus 7 can equal 0, so x can't equal 7. Now we're just going to multiply across. So on the numerator, I'm going to have negative 3 times x minus 7 times x plus 4 times x minus 4. And on the denominator, I'm going to have negative 2 times x plus 2 times x minus 7. And I have to add the restriction that x can be equal to negative 2 or 7. And one more thing I can do is I can cross out an x minus 7 on both the numerator and denominator. So then this reduces down to negative 3 times x plus 4 times x minus 4 over negative 2 times x plus 2. But we keep the same restrictions that x can't be equal to negative 2 or 7. Let's take a look at number 3. So in this case, it looks like we're dividing two rational functions. So why don't we rewrite this in a more readable way? So this is going to be 4x minus 24 over negative 3x minus 15. And then this fraction is saying that we're dividing by x squared minus 36 over x plus 5. So dividing by x squared minus 36 over x plus 5. So now why don't we factor everything here? So we can factor 4x minus 24 by factoring out a 4. And we're left with 4 times x minus 6. And then over here we can factor out a negative 3 from both of those terms. So we're left with x plus 5. In the second term, we can factor x squared minus 36 using difference of squares. So then this becomes x plus 6 times x minus 6. And then the denominator of this one can stay the same as x plus 5. Now we can add our restrictions, right? So we need to add that x can be equal to negative 5. And that's the same restriction for this one. X can be equal to negative 5. Now we can go ahead and use keep, change, flip. So the first term stays the same. We keep this. The second term, or the sign changes from division into multiplication. And then the third term, we're going to take the reciprocal of. So we have x plus 5 over x plus 6 times x minus 6. And what we can do now is add another restriction that x can't be equal to negative 6 or positive 6, right? Because we can't have that denominator equal to 0 either. Okay, now we can simply multiply across. So our numerator is going to be 4 times x minus 6, that's this numerator, and then times x plus 5. And the denominator is going to be negative 3 times x plus 5 times x plus 6 times x minus 6. Okay, now we can cross out this x minus 6 since it's on the numerator and denominator. We can cancel out that factor, and we're left with 4 times x plus 5 over negative 3. Oh, I didn't realize we can also cancel out this x plus 5 on the numerator and denominator and make it even easier. So then this is actually going to be just 4 over negative 3 times x plus 6. We still keep the same restrictions, so x can't equal negative 5, 6, and negative 6. And that's our answer. Let's look at one last problem for multiplying and dividing rational expressions. So for this one, what we're going to do is, actually we'll skip this one for now. Let's move on to solving rational equations. So when you're solving rational equations, it's going to follow a lot of the same rules as solving regular fractional expressions, right? So let's start with this one, right? First thing we need to do is add the constraint that x can't equal to 3, 3, and 1, right? Or just x can't equal to 3 or 1, because again, our denominators can't equal to 0. Now what we're going to do, just like regular solving with fractions, is we're going to cross multiply. So I'm going to multiply these two and these two, right? So I'm going to have x plus 1 times x minus 3 times x minus 1. And then that's going to be equal to x minus 3 times negative, remember this negative of x squared minus 6x plus 1. So we're actually going to have to apply this negative to this entire polynomial, alright? So let's simplify this a little bit. I'm going to multiply everything in here by negative 1. So then that's going to become negative x squared plus 6x minus 1. And now what we can do is, notice how we have an x minus 3 on both sides of our equation, so I can cancel that out. And I'm left with x plus 1 times x minus 1. And if I multiply that, it's going to end up being x squared minus 1. And then that's equal to negative x squared plus 6x minus 1. And what I can do now is just move everything to one side. So I'm going to subtract both sides by x squared and add 1 to both sides. So once I do that, I'm going to end up with negative 2x squared plus 6x equals 0. So now what I can do is factor out a negative 2 from both of these terms, or factor out a negative 2x, and I'm going to be left with x minus 3 equals 0, and then the solutions are when negative 2x equals 0 and x minus 3 equals 0. So our solutions are x equals 0 and x equals 3. But remember from up here that in our original expression, x can't equal 3 or 1. So we need to respect that. And so then this is not going to be a solution. And we're just going to have x equals 0. Let's take a look at another rational equation. So once again, we're going to set our restrictions. X can't equal to negative 1, or negative 2. So in other words, x can't equal negative 1 or negative 2. Now, again, we're going to cross multiply. So we're going to have x minus 3 times x plus 1 times x plus 2 equals x plus 1 times 4x minus 6. Again, I can cross out x plus 1 from both sides, and I'm left with x minus 3 times x plus 2, and when I multiply that out, it's going to end up being x squared minus 6x. Let's see, not minus 6x, let's x squared minus x minus 6, and then that's equal to 4x minus 6. And again, I move everything to one side, so I'm going to subtract both sides by 4x, add 6 to both sides, and I'm going to end up with x squared minus 5x equals 0. Factor out an x from both of these terms, and I get x times x minus 5 equals 0. My solutions are x equals 0, x equals 5. And that doesn't conflict with my restrictions, so then I can have both of these as my solutions. Let's do one more problem for solving rational expressions. So once again, I'm going to add my restrictions that x can't equal 3, 4, or 4. Now I'm going to cross multiply. So I'm going to have 17 minus 3x times x minus 4 equals x minus 3 times x minus 4 times x plus 1. Once again, I can cross out x minus 4 on both sides. On the left side, I'm just left with 17 minus 3x. On the right side, I have x minus 3 times x plus 1. And when we multiply that out, that's going to give me x squared minus 2x minus 3. So I'm going to move everything to the left side, and I'm going to end up with x squared plus x minus 20 equals 0. If I factor this, I get x plus 5 times x minus 4 equals 0. My solutions are x equals negative 5, x equals 4. And remember, I can't use 4 as a solution, so this goes away, and my only solution is x minus 5. So that's it for solving rational equations. Now we're going to take a look at some SAT problems. So let's look at this first one. It says which expression is equivalent to 8x times x minus 7 minus 3 times x minus 7 all over 2x minus 14, where x is greater than 7. So let's see how we can approach this problem. Notice how both of these terms, now what you could do is you could multiply out this and multiply out this and try to solve it that way, but that's going to take a lot of time, and it's not worth it when there's an easier way to do it. Notice how both of these terms have an x minus 7, right? What we're going to do is factor out an x minus 7 from both of those terms, so we're left with x minus 7 times 8x, right? When you factor out x minus 7 out of this, you're just left with 8x. And when you factor out x minus 7 out of this, you're just left with negative 3, right? So 8x minus 3 all over. And I'm going to factor out 2 from both of these terms. So I'm left with 2 times x minus 7. Notice how I can now cross out x minus 7 on both sides. And I'm left with just 8x minus 3 over 2. And that is a solution, so that's the one I'm going to use. Let's look at another problem. So this one says the equation above is true for all x is greater than 2, where r and t are positive constants. What is the value of r times t? So let me rewrite this over here. So we have 2 over x minus 2 plus 3 over x plus 5 equals rx plus t over x minus 2 times x plus 5. So notice how it looks like they found a common numerator and denominator by multiplying these two denominators, right? So that's what we're going to do. We're going to use x minus 2 times x plus 5 as our common denominator and convert both of these fractions to have that common denominator. So let's start with this one. Notice how we already have the x minus 2 part, so we're just missing x plus 5 for this first fraction. So I'm going to multiply both the numerator and denominator by x plus 5. and I'm going to be left with 2 times x plus 5 over x minus 2 times x plus 5. For the second one, notice how we already have x plus 5. So we're missing this x minus 2. So that's what I'm going to multiply both the numerator and denominator by. So then I'm left with 3 times x minus 2 over x minus 2 times x plus 5. Now I can add these and keep the denominator the same. So I'm going to be left with 2 times x plus 5 plus 3 times x minus 2 all over x minus 2 times x plus 5. And what I can do now is simplify this numerator. So if I simplify the numerator by multiplying out this and this, that's going to give me 2x plus 10 plus 3x minus 6 all over x minus 2 times x minus 5. Times x plus 5. And now what I can do is combine like terms over here. So 2x plus 3x is 5x, and then 10 minus 6 is 4. So 5x plus 4 over x minus 2 times x plus 5. And notice how if I compare 5x plus 4 with rx plus c, we can see that r is equal to 5 and t is equal to 4. So then r times c is 5 times 4, or 20. Let's look at another one. It says which expression is equivalent to 4 over 4x minus 5 minus 1 over x plus 1. Again, this is just going to be a basic subtracting rational expression. So we have 4 over 4x minus 5 minus 1 over x plus 1. So what we're going to do here is first find a common denominator. So I'm just going to multiply 4x minus 5 times x plus 1. So my common denominator is going to be 4x minus 5 times x plus 1. So to get to this common denominator, notice how I need to multiply this one by x plus 1 on both sides. So then this becomes 4 times x plus 1 over 4x minus 5 times x plus 1. And then for this one, notice how I already have the x plus 1, so I don't need to multiply both sides by that. But I do need to multiply both sides by 4x minus 5. So for this one, I'm going to multiply both the numerator and denominator by 4x minus 5. And then I'm going to be left with 4x minus 5 over x plus 1 times 4x minus 5. And now what I can do is perform this subtraction. So first I'm going to change 4 times x plus 1 to 4x plus 4. And now what I'm going to do is subtract these, and when you subtract these, you need to apply the subtraction sign to both of these terms. So it's going to look like this: 4x plus 4 minus 4x minus 5. So notice how both of the terms are in parentheses and the subtraction sign is being applied to both of them. And then this is all over 4x minus 5 times x plus 1. So now I can subtract these. First, I'm going to apply the subtraction sign. So when I distribute the subtraction sign into both of those terms, this is going to give me 4x plus 4 minus 4x plus 5, right? And if I combine like terms, 4x minus 4x is 0, and then 4 plus 5 is 9. So then this becomes 9 over 4x minus 5 times x plus 1. And let's see, that's going to be answer choice D. Let's take a look at this one. It says, in the expression above, b and c are positive integers. If the expression is equivalent to x plus b and x is not equal to b, which of the following could be the value of c? So what we're going to do here is, if you think about this, it says this entire expression, x squared minus c over x minus b. This is somehow equal to x plus b as long as x is not equal to b. So if you think about this, right, what it's saying is that the denominator was sort of eliminated, right? So what if we replace this numerator x squared minus c with x plus b times x minus b, right? Notice how in this case the denominator is going to cancel out with the numerator and I'm left with just x plus b, right? Which is what I want. So what we can say is that our numerator, which is x squared minus c, must be equal to x plus b times x minus b. Because if it's equal to x plus b times x minus b, then our denominator cancels out. So if x squared minus c is equal to x plus b times x minus b, let's see what we can do to find c. It's saying which of the following could be the value of c. So what we're going to do here is I'm just going to multiply out this right side. So if I do that, I get x squared minus bx, x squared minus bx, and then plus bx minus b squared. Notice how minus bx and plus bx cancel out, and I'm left with x squared minus b squared is equal to x squared minus c. So it's looking like c is equal to b squared. But they didn't give us any number. They didn't give us b squared as an option, right? They give us numbers as options. So we need to find the exact value of c. So let's think about how this could be. We know that x squared minus c is equal to x squared minus b squared, right? So, and x squared minus b squareds needs to be able to factor into x plus b times x minus b. And remember that this pattern where you factor x squared minus b squared into x plus b times x minus b, this pattern is called the difference of squares, right? And for that to work, this b value needs to be a perfect square, right? So if we examine these answer choices, all of them are not perfect squares except for this one, right? So only 4 is a perfect square. So this would actually only work if you had x squared minus 4. You can factor that into x plus 2 times x minus 2, right? But that wouldn't work if you had, let's say, x squared minus 6, right? You can't factor that into difference of squares because 6 is not a perfect square, right? So that means that c must be equal to 4. Let's take a look at another one. It says, which of the following expressions is equivalent to f of x over g of x for x is greater than 3? So what we're going to do here is we're just going to divide f of x and g of x. So we have f of x is x cubed minus 9x. G of x is x squared minus 2x minus 3. I'm going to factor the numerator. So I'm going to pull out an x from both of those, and I'm left with x times x squared minus 9. And on the denominator, I'm going to factor this, right? So two numbers that add up to negative 2 multiplied to negative 3 are going to be x minus 3 times x plus 1. And now I can actually further factor my numerator, right? Because x squared minus 9 is difference of squares. So then that becomes x times x plus 3 times x minus 3 over x minus 3 times x plus 1. So I can cancel out x minus 3 on both the numerator and denominator, and I'm left with x times x plus 3 over x plus 1. And that's going to be answer choice D. Let's look at another one. So we have the equation x squared plus 6x minus 7 over x plus 7 is equal to ax plus d. It's true for all x's not equal to negative 7, where a and d are integers. What is the value of a plus d? So let's try factoring x squared plus 6x plus 7. If we factor that, two numbers that add up to 6 and multiply to negative 7 are negative 6 and negative 1. So then we have x minus 6 times x minus 1 over x plus 7. And then that's equal to... Sorry, would this work? Yeah, that'll work. would they? Actually, no, that's incorrect. I'm sorry. So negative 6 and negative 1 don't add up to positive 6, right? Obviously. The numbers that we're looking for are 7 and negative 1, right? 7 plus negative 1 is equal to positive 6, and 7 times negative 1 is equal to negative 7. So we're going to have x plus 7 times x minus 1 over x plus 7, and then that's equal to ax plus d. So notice how we can again cancel out x plus 7, and we're left with just x minus 1 is equal to ax plus d. So we can see that a is going to be the coefficient of x, which in this case is just 1, and d is our constant term, which is negative 1. So then the value of a plus d is going to be 1 plus negative 1, which is just 0, right? So then 0 is our answer. So that's all the practice forms that we have for today, and that's the end of this lesson.